Next speaker is going to be Matan Hart with Symptom.
Thank you, Adam, and the entire attack team for having this, giving you the opportunity to present. You're doing an amazing job. Huge fan here. I'm going to talk about today is how you can transform adversary emulation into a data analysis question using the MITRE attack framework and specifically the mitigation in the attack framework. About myself, usually I look like in the picture on the left side, but during COVID, I might look like this. I'm a co-founder and CEO at Symptom, a security startup specializing in security testing. I've been a security researcher in the Israeli Defense Force and as well as in the private sector. Some of my research I've been presented in several security cons such as Black Hat. And actually, the inspiration for the content that I'm talking today is based on my existing work building solutions and conducting security assessments for large organizations. And click. Great. So let's start with adversary emulation. Other side, I have an issue with the clicking. Great. There is a lag a bit. Sorry about that. So adversary emulation, for those of you who need a recap, is the way that has been used popularly, one of the most useful use cases for the attack framework, which is basically allow the organization to test their defenses against specific threats. The attack framework can be very beneficial to measure, test, and then also make improvements to defenses based on the different adversary tactics, techniques, and procedures. But the problem with adversary emulation is that it doesn't scale, nor it wasn't intended to. Basically, the main focus of adversary emulation is to test specific controls in a controlled manner that is very targeted, specific network, and emulating a specific threat. The issue with it is that some organizations are still early on during their work with the attack framework, and they basically want to get an initial state of where they're standing with their defenses against the metrics. And what I've seen that basically some organizations are trying to emulate all attacks, all in the network. I've seen one time that there was an organization with 50,000 endpoints where they needed to emulate a lateral movement technique used by an APT, and they had and they figured out only where after they used some kind of automation that they literally emulated 2.5 billion emulation because they tested it from each computer to all of the other computers in the network. So it was a big number, and it's actually made a huge disruption to their network. So what I'm suggesting is to a different approach using the MITRE attack matrix framework that basically instead of checking detection capabilities that are the most commonly used with adversary emulation, is to basically look at the aspect of the mitigation of the attack framework. And testing each technique and the associated mitigations if you really have the right capabilities to prevent this technique before going on to detection. So the methodology is have 4 steps. First of all, choose an attack technique. You should preferably choose the technique that you feel more you want to have the first initial, that you feel comfortable that you want to test first. If you're already mapped techniques to detection capabilities, so you should preferably start with something that you feel that you don't have enough data sources or detective capabilities in place. Then for the technique that you choose, you should test for each mitigation how much it's effective, because not all of the mitigation that are in the attack framework are having the same they're reducing the same attack vector. Some of them are just reducing some of the attack surface or the exploitability of that technique, and some of them are truly mitigated the technique entirely. After you grasp those techniques that you want to focus on, you should map the data sources that you can really collect the information needed in order to validate the applicability of that mitigation. Preferably, you should do it for all the mitigation for that technique in order to make sure that you're not missing any information. But in generally, as mentioned also by previous speakers before me, it's not science, the attack framework, and you don't have to be 100% all the time. And it's okay that even if you feel that it's not 100% accurate or don't have access to all the information, you can still be able to have the initial state to conclude if a specific technique you are able to prevent in your what is your current situation with that technique, and how much is exploitable in your network, not on specific endpoint, rather on the entire attack surface inside a network. Let's take a test case, the Pasadena Hash scenario. Basically, Pasadena Hash is a lateral movement and defense evasion technique that allows an adversary to move laterally between endpoints based on credentials that they can reuse, because those two users have the same credentials. It's very common between endpoints that are used by the same image, and the default built-in users their password are not changed after they've been deployed, and something that is still very common to see in organization, and it's something very hard to really know what has been changed or not. When we're looking at the mitigations in the attack framework about this specific technique, there are basically 4 different mitigations that offer different. They have different ways to mitigate this technique. However, not all of them are actually doing the same, and also their exposure that they are reducing or eliminating is not the same. So when you drill down with the small letters, first of all, you can understand what is really need to be checked, what data should be collected, and then you can move on to do a bit of research. It's not something that is very easy, but we took here a case that is more harder. There are some that the mitigations are more straightforward. But when you check each mitigation specifically, you can see that their effectiveness is not always the same. So of course, if you have the capability to check if there is any type of credential overlap, the first mitigation, which is privileged account management, if you use labs or you have access to endpoints and check the registry, or whether you have a PAM solution that you can use to assess, this is the best mitigation that you could check and you could also enforce. But of course, life are not perfect, and if you're looking for other mitigations that could potentially reduce the attack surface, you should consider checking for your patch management, if you install the right patches that the MITRE mitigation suggests, as well as which will mitigate the exposure only to administrative local accounts. You could go with the user account control mitigation, which is aimed more for domain users, but it could be easily checked by checking the Active Directory in the GPO to see if there is or users that have multiple systems that have administrative access, that the same user have this administrative access to both of them, and maybe you should consider focusing on that mitigation as well. Other effective mitigation that is being used in the frame that is commonly seen in organization that is easy to implement is the user account management. Is basically enforce some UEC restrictions using the GPO. If you don't trust your GPO, you could also, if you have the capability to query each endpoint registry and look for the right keys, which are also mentioned in the MITRE mitigation, in the attack mitigation. And basically, if you don't have, if your built-in administrator account is disabled, this is a very effective mitigation to eliminate the local variation of local account variation of the Pasadena Hash attack technique. And of course, you can do a talk about the attack framework and not show a fancy heat map. So here's my heat map. What we focus here, which is the important difference, is that we are not mapping detective controls. We are checking only if the existing mitigations are applied. So if you already built a heat map that shows your detection capabilities, this heat map could look very different. And I suggest to use it as a complementary to the techniques that you feel that you don't have enough detection controls. If you don't have already and you want to focus and you start we start from square zero, I feel it's better to start actually with this heat map. And then if you feel comfortable with preventing some of the attack techniques, you should focus your detective controls for other techniques in the MITRE framework. So those you can build even interesting attack a heat map that contains how many of the techniques you are able to prevent using preventing controls using the mitigations in the attack framework, and how many of those you only able to detect. So it's interesting use case to know to make a defense gap analysis first with mitigation and then also with detection. So it's important to mention that there is no you need to pick the right tool for the right job. Adversary emulation is great. I've been doing it also for years. It helps organization really to know really where they stand, and it also check how your also people and processes are performing. The issues that makes adversary emulation to not to scale is the potential business disruption that it might create, and also the experienced team that should do it in a safe manner. Data analytics, on the other hand, could be a good complementary to first get the right coverage in the attack framework, as well as the network coverage in a safe manner that could scale better. I suggest to start with data analytics if you don't perform adversary emulation yet, and then based on the results that you can map from the attack matrix in order to check your detective controls, or to see how you can really check that the mitigation that you've implemented are performing as intended. Adversary emulation could be a good use case to check this. The issues with data analytics is that, first of all, it doesn't check detective controls, which is of course one of the main use cases that people use the attack matrix and the attack framework, and it doesn't really check any type of processes. To conclude the presentation, first of all, adversary emulation are great, they're important, and it's something I suggest everybody to practice, even if you're not in the red team. Also, blue teams can use the atomic red team, which Brian talked about, but as well, it's something that you should use cautiously. It's something that you don't really want to run it in all for your network. Rather, you want to do it specifically to check specific controls and in a control environment. Data analytics, on the other hand, could be a better approach to get the initial state of where what is your defense coverage, and to know where you stand, and then you could operate and implement new capabilities, whether preventive or detective. And I found the mitigation in attack very beneficial to understand what is defense coverage, because first of all, most of the techniques in the MITRE framework, and basically most of the controls that most organizations have in the organization, are first of all preventive, and of course should be preferred. So I found the mitigation in attack something that is not should be used more often during any type of usage for the attack framework.
Great talk, Matan. That was fantastic. I really loved. Someone dropped a comment in Slack that you're effectively emulating the adversary emulators. But like you said, getting ahead of them and saying, before we even if we don't have the resources to do an emulation, or before we do it, let's go ahead and figure out like what are we doing in terms of the mitigation aspect. But I think a lot of people really appreciate it, and that resonates with them. Biggest question though, I think a couple people are already asking this in Slack, is what advice do you have for the community in terms of the process that you shared of, looking at attack, seeing the mitigations for a technique, and actually translating that to, what can we do in our environment? How does that line up with our technology? What any words you can share with the community and any wisdom you can kind of bless with there?
Great. So first of all, I think as also discussed in the previous talks, and I guess it's something that we learn with attack on a daily basis, that it's the human aspect. You can't really automate everything, and there is a magic. Of course, you should. It requires research, it requires work. I took an example, the Pasadena Hash, because it's an interesting case and it's a bit complicated. Of course, some of them are much easier to start with, but yes, the process is to research, is to learn, and to be familiar with the different tactics and techniques, and to be able to really understand and research what are the current capabilities that people have in this organization that they can really check. Of course, good cyber posture and hygiene helps. And if you have the right tools and the right controls, or use vendors that help you automate some of the stuff, it could be easier. But for most techniques, I found it that it's pretty trivial. I do think that it's part of our work as a community to also invest in the mitigations, in the attack even more. I know that those are also now the shield, and of course we're going toward how we can all as a community be able to share more and make that process easy.
Yep, love that answer. Like you said, cybersecurity is hard, but I'm loving the contribute plugs. Like I said, by all means, keep contributing back to us. We love it. But yeah, thanks again for a great talk.